All right, thank you very much, all. It's been a Rust presentation a moment ago, so I hope like Haskellers stay in the room, because who hasn't seen Haskell before? All right, a few people. Well, you'd be surprised. All right, so this talk is about Effectful, and it's this awesome library that is Effect library, and I wonder what that is. It's supposed to be fast, extensible, a lot of cool features, a lot of cool words, whatever those means, let's find out. And we only have 25 minutes to do it, so I'll try to be this guy as much as I can, and let's see what happens. If we don't make it, just find me in the lobby after this talk. All right, so why to even bother about effect systems? Well, somebody, a prominent organizer of this conference once said that effect systems are just a way of programming to the interface. And I would say, yes, maybe, no. It's almost like calling a tank a vehicle. It is a vehicle, but it's so much more, right? So when I talk about effect systems and what they give me is this like a very good precision with dealing with complexity in the systems that I try to build. And this talk is trying to persuade guys that that's actually the case and how Effectful, as a library in Haskell, can help us do that without losing performance, or at least much of it. So an example, imagine that you're at 9 a.m. in the room, you are, your colleagues from your company, there's obviously a Scrum Master, and you have this new user story you have to implement, right? As a user with system administrator access rights, I can deactivate user in my system. And while your Scrum Master is already pulling poker card for poker game or whatever, you're already thinking how you're going to implement this system. Because you're thinking, okay, we have LDAP for authentication authorization, so we have to like do a little bit of digging in that area. And we have to suspend logging in LDAP. We have a CRM system which runs on Postgres, so I have to delete a row in that table. So you're already thinking about all that stuff you have to do. And while the meeting is already bike-shadowed by some question, you already have a pretty much idea how you're going to implement that. And this is a little bit of pseudo Haskell code using MTL. This is how you could implement this deactivation, where you check whether you have those access system administrator access rights, and that is calling some functions from like LDAP get attribute, and then checking if the right exists, and then if it doesn't, you throw an error. If it does, you deactivate, and yet again, deactivation is just calling LDAP functions and some delete entity in Postgres, and all that could be either library calls or type classes. So if they are type classes, you potentially can mock this in your unit test. So it's pretty much all good, but it's not ideal, because this is just going from like a high-level idea of deactivating a user under given circumstances to very low-level concerns. So the problem might occur immediately the moment, for example, your organization figures out we're not going to authenticate our users in LDAP anymore. We're going to switch that. And now all your nice little test units, all of that breaks because all of those constraints were intertwined with each other. So there still might be interface in that. There still might be a way of mocking this in your unit tests. That ain't gonna last while the project grows. It's just simply not gonna scale. The way when I see the user story like that, I think about different concerns in that user story. So I see authentication, I see authorization, I see account management. Those are 3 separate things, and we could even say that there are 4 separate things, because you also need to handle errors. All of them, they have their own little language with their own little terms, right? What does it mean to be a logged user? What does it mean to have an access right? And each of those concerns, you can deal completely separately. That user story will bring them all together in one nice tiny little function. But you should supposed to treat them as separate things, deal about them, and think about them separately. But the user story, once you have that language defines for the different concerns, is pretty much straightforward. As a user, given the access rights, I can deactivate account. So that little separation of concerns is a really nice thing. But that's just one dimension. Okay, we have a user story, we have separate concerns. But now let's take one of those concerns as an example. So for example, account management. when I'm talking about deactivation of a user, I don't want to immediately just, again, go into like lower level concerns, like immediately just drop something from database or dig into my LDAP. Yet again, I would like to separate complexity and layer by layer, removing that complexity from my system. So in terms of that one single term from that language, deactivation of user, because we have here another one, create account or whatever, what does it mean to deactivate account in our system? Well, that might mean dropping all the access rights, suspending authentication, and lastly, deleting the account in the CRM system. Okay. Do I need to directly go to a library code? Not really, not necessarily. What I can do is, I always think about it as going from higher level language to a lower level language. So in that case, whenever I deal with deactivation, I want to drop all rights, authenticate suspension, and delete the user in the CRM. And those are separate terms in lower level languages, because now I can define a separate level language where I want to talk about authorization. I need to go to the left for the camera. Okay. I hate this stuff. Okay, but anyway. So now, when I talk about account management, I see this as a high level language, and when I talk about this idea of deactivating a user, I try to describe that concept in terms of lower level terms from lower level languages. In that particular example, those languages are authorization, authentication, and CRM administration, where they have their own little vocabulary. Each of those languages have their own terms. So once I have that deactivation of users is basically those three little steps. And you see that we transform one language, account management, so a program described in that language, to a program that's described in terms of those three lower level languages, just going one layer down. And then what is a lower level language for one might be higher level language for something else. So that yet again, that previous authorization language, now we can treat it as a higher level language, and for it, lower level language will be LDAP. A direct LDAP calls that will do whatever they need to do in order to drop all rights. So for example, in this example, dropping all the rights is getting the attributes called rights and removing them from LDAP. And I can do, so yet again, authorization, so program defined in authorization terms goes into a program which is defined in LDAP terms. And I can do the same thing for authentication, which also authentication in my example uses LDAP, and the same goes for CRM administration, which in my higher level language there is a term delete CRM user, and in that particular example, that means just SQL delete from Postgres. So yet again, from that language, program defined in CRM administration language, I go to program defined in Postgres CRUD language. So the idea is that given that I have a program defined in some high-level language, I can transform it, interpret it into a program that is defined in a new language, which is built combined of sets of different languages, lower-level languages. And the nice feature about it is this sort of composability, whereas, for example, I could have a program defined with terms from language B1 and B2. Those can be interpreted, so B1 can be interpreted with C1 and C2, B2 can be interpreted with C3, and then I can compose those interpreters together to get a new one, which goes directly from my higher level language A to something that's being defined in C1, C2, and C3. So why this is cool? Well, this is cool because right now, I can, once I have account management defined in those three, I can have a program being built on the language account management. I can have one interpreted to those authorization, authentication, and CRM administration. Those goes directly to LDAP and SQL. So with that composability, I can have a high-level language that even my stakeholders understand, people I met daily when I talk about user stories and features. So they understand high-level language, but they can transform that to something low level, which is very close to bare metal, because later on, those LDAP and SQL will be directly interpreted to I/O. Now, for me, this is the pure value of working with any effect system or MTL of some kind, because that gives you this actual reusability that object-oriented promise, and I think FP delivers. Because if you really think about it in this particular example that I built, if we look at the programs, the account manager is very feature specific. That, as I said, that's the highest level language that the product person can understand. Anything below, okay, I thought there was more slides to it. I was modifying those slides 5 minutes before this talk, which is probably a bad idea. And in my country right now is 2 a.m. in the morning, so you got this now. Just stay with me, right? But you see that if those 3 other languages, authorization, authentication, and CRM administration, are organization specific, if authentication changes within the organization, that will probably change not only in that particular code base, it probably will change in different code bases throughout your whole organization. Whereas the LDAP and SQL are, if they are not already a library code, they probably should be, and they will probably outlive your organization. So those consents, so remember how we define the user stories here into those 4 different columns, and now each of those columns we also slice into specific consents where we start with something high level when we end up with something which runs directly on an I/O. And Effectful is a library that allows us to do that. So, really quickly, I have 20 minutes. Okay, not that quickly. Okay, so all right, I don't have to be an Eminem anymore. The idea is simple. You define JDT, which defines that higher level language. In our example, that's create account and deactivate account. Let's focus on the deactivation of account, where we take a user ID and we have this data constructor, deactivate account, which takes that single argument and builds us the account management. Now, that is just only for building that language. We would need to define functions that correspond to those constructors. If you're keen to template Haskell, you can just have that one little line, and that will do the magic for you. But if you don't, those are pretty much trivial. You take the constructor of your language and you call function send on it, and that's pretty much it. So nothing really fancy. The important bit is that now you get, as a result, those functions, the create account and the activate account, they return, as you see, this type called F, whatever that is. So F is parameterized by 2 things. S is a list of type level list of effects, and res is result. So whenever you see a function returning anything like that, you're supposed to think in the following way. This is a program that will, when run, will return a value of type res, while it is constrained on the things that it can actually do, defined only on the effects defined on that type level list, ES, right? That's pretty much it. So if F is going to only have account management on that list, you know it can only do that and nothing else. It cannot possibly nuke other country or whatever. You're constrained on the things that you can do as a developer or interpreter who will run this program. So deactivative account, as you can see in this particular example, it's telling us exactly that. That little constraint over there is telling us that we have a list of effects, ES, but we're saying account management is one element on that list. It doesn't have to be the first element on the list. It has to exist on that list, and that's it. So when you look at that function, we don't even know how the function works, but we know when we look at this that it will return unit once run, once interpreted, and the only thing that it can do is whatever account management allows it to do, which is yet to be defined. So here's a simple program in which I use those two functions that we just saw a moment ago, create account and deactivate account. So I create account with a login encode panda, and immediately I deactivate it. So this program, yet again, is just constrained to account management language, and that's it. I cannot really put anything to the console. I can blow up a bomb somewhere. That's anything I can do is define in that one particular language. Now, the question would be, how do I run it, right? Because essentially, I want to have an I/O. That's the main function in Haskell. Now, what do I do? Luckily, we have the underscore feature, which is the most greatest thing the Haskell compiler has. And people, whenever I'm showing them Haskell and I show the underscore, they always say, like, why no one is talking about this? I'm like, I know, right? But anyway, the underscore will tell us, I found a hole, I need to go from F to I/O. I'm like, great, I knew that, right? And if you look at the library, you will find this function run F. So it's not necessarily what we have, but being a junior Haskell developer like myself, I'll try it anyway and see what happens. So if I call this run F on my program, even though the type signature was not really exactly what I was hoping to have, I actually get a really nice compilation error because it's telling me that I cannot call this function yet because I haven't handled the account management. We know the program wants to create an account. We know it wants to deactivate the account just the moment it created it. But what does it mean? What does it actually mean to create an account or deactivate it? We need to handle this language. And as you remember, that account management deactivation was using authentication, authorization, and CRM administration. So we can create representation of those lower level languages in Effectful one more time. And we will do it exactly as we did for account management. But we now are doing this for our lower level languages. So we will have things like has rights, drop all rights, right? And we will have those functions, either we have to write them by hand or template Haskell will create them for us. Same thing goes for authentication, where we have things like who am I or suspend or login. And the same thing goes for CRM admin functions, where we have ability to create user and delete user. So we've created 3 different languages. All of them have their own little terms. And now, as you remember, account management was supposed to go from, we were supposed to go from program that uses account management to a program that uses those terms from these 3 different languages. And that's what we do. So we will write a function, an interpreter called run account management that does the following. If you look at the type signature, it's straightforward. It's telling you, if you have a program that was defined with this effect, account management, I will give you a new program, modified, where that effect is no more on that list. It was interpreted with different effects. And with what effects? Well, the facts exactly those. We're saying we can only provide this interpretation only if on that list of effects, additionally, there are those 3, CRM, authorization, and authentication. Once we do that, we can call interpret function, and for each term in our high-level language, in this case, deactivate account, we tell what it means to deactivate account in terms of those lower-level languages. So we want to drop all rights, suspend the account, and delete the user in the CRM system. We still don't know what that means because we didn't go directly to LDAP calls. We didn't go directly to Postgres calls. We're just saying we need to drop rights, we need to suspend authentication, and we need to remove this person from CRM, and that's it. So now, yet again, so now that I have a program, I can interpret it. So I start with a program that has account management, authorization, CRM, and authentication on the type level list. If I run it, I only end up with those 2. Now, I have to repeat that process of interpreting those languages for those low-level languages as well, right? Pretty obviously, like we started with the higher level one, now we need to interpret the lower-level ones. The beauty about this approach, and I will just go into code in a second, but the beauty about this approach is that for the lower-level stuff, we do it once. we have it as a separate concerns, keep it in a single module, and we do it only once. If we're going to have a new user story a minute create account, right, we're going to most likely reuse all existing lower level stuff. That's going to be there. I don't know how many minutes, probably 5. All right, we should be good. All right, so I'm doing exactly the same thing for those low level languages. So I need to do an interpretation. And interpretations, just to interpret it, I need to have languages like LDAP, so those the lowest level stuff, like close to bare metal, right? So I need to know how to drop attributes, get attributes, suspend, and I need the same thing for Postgres. I need to create, insert into a table or delete from a table. And once I have that, I can exactly say what it means, for example, to drop all writes. So I'm getting attributes and I'm dropping those attributes, or suspension is just calling suspend. Or deleting a user from CRM system is just deleting a single row in a single table. That interpretation, now, once I have my higher level program, started with that list, we interpreted the first effect, then interpreted that one, and now we're just left with LDAP and Postgres. Now we're just left with like very low level stuff, for which, yet again, we most likely have a library code somewhere on Hackage exists, a thing that deals with LDAP and with Postgres, and whatever library you choose, you write interpretation for it, and the same way as we did before, so I'm just going to skip over slides. And lastly, we just run that interpretation for LDAP, run that interpretation for Postgres. By the way, those interpreters, the one thing that I missed showing, they were having at least they're supposed to have, interpreters, they're supposed to have this one little effect. If your F has effect IOE, which is a thing from the library, then F has a monad IO instance, and you can lift any IO operation to do it. Eventually, we just end up with this, and as you remember, we had function runF. That told us if you have a program which deals with only single effect IOE, then I know how to go from that program into IO, which we run, and essentially we get an IO back, and now our program runs. That's great. So someone who knows Polysemy might be, well, is it just Polysemy then? Well, from ergonomics point of view, it is. From implementation point of view, it isn't. Polysemy is underneath a free monad, whereas Effectful is the ReaderT. And that's in a second. So you guys, Haskellers, might be thinking, oh, that must be super slow, right? It's like, if it's like Polysemy, it must be slow, because the simple answer is no. It's actually pretty cool, and it's actually pretty fast, given that I have 3 minutes. So I will have to skip a few slides, but essential takeaway points are, we as everyone have folklore beliefs. And it's nothing to be ashamed of. That's just the nature of being a human being. And Haskellers have one particular folklore myth and belief, and that is that MTL is extremely super fast. And if it turns out, not always. And if you haven't seen this talk, you should. And you have seen this talk, you should see it at least twice or 3 times in a row. And there's an explanation why that is, and MTL is not always the super fast way of doing things. I will just show at the very end benchmarks for Effectful. So if you don't see the font, don't worry about it. I'll tell you exactly what that is. That super long line, no, it's not Polysemy. It's actually fused effects. So let's just take it out of equation. The very bare metal IO thingy for the benchmark was running in like something between like 9 microseconds, whereas Effectful was somewhere between 20 and 50. So it's really not that bad, especially if you think about it, that now the longest line that you see in this benchmark is actually MTL. And this is the deep MTL. The deep MTL means, okay, the deep MTL is the closest thing you will get in that benchmark. The benchmark, when they are marked with deep, are closest you normally get in production. Because in production, normally you have a program which have a bunch of interpreters, but their actual function is using just few of them. But nevertheless, it goes through interpreting all of them. So MTL sucks. And then the Polysemy is actually better than MTL at this point. But Effectful is really close to what you would normally get just with running with I/O. Because, and just have to skip through this, blah, yada, yada, because that's really what it is. That's essentially copy-pasted from the library code. EFF is, and it's not even a ReaderT. It's just a function from environment to I/O. So if you know the ReaderT pattern, where within the ReaderT you hold every mutable thing you can have, and it's just a ReaderT of that stuff over I/O, and you've read Michael Slim's blog post about it, that's pretty much it under the hood. It just rubs that ugliness of that and gives you rather nice ergonomical combinators that you can use and interpretation functions. And gives you, I would say, a nice usability of Polysemy with effectiveness of ReaderT pattern. Some mentions here, like if you use Polysemy, you know higher order effects, they just don't work on Polysemy, they do in Effectful, which is pretty cool. And they get rid of all the MTL gotchas, if you know what they are, and probably most of you guys know, they are all removed, so no problems with state, with writer, and anything like that. I really like the very first issue on Effect Library is awesome, because the author of Effect, like this is, even if you're not gonna use Effectful, but you won't just wanna be better Haskeller, just go through this issue, because he went through every ticket in Polysemy ever created, and he just double checked if it's a thing in Effectful, which I think is amazing. It's just like, I don't know, super cool thing to do. Read some Reddit discussion. Anyway, that's my name, that's my Twitter if you want to complain, and thank you very much.